So this is going over activity number 8 together. So the first problem is asking you to sketch the graph. I write out the t-table already to find some function values. And therefore, all I need to do afterwards is to put those points on the graph. So negative 2.001 somewhere here, negative 1.01 a little bit higher, and 0, 1, and then 110. And 2, 100 is outside my graph, so this is what I end up with, which is 2 to the x. My other graph goes with negative 2 is 100, negative 1 goes to 10, and then this point there. So as you can tell, there's a perfect symmetry between those two graphs. My bad, it was 10 to the x. And this was 1 over 10 to the x. As a matter of fact, it's 10 to the negative x. So they are symmetric with respect to the y-axis. It's a reflection with respect to the y-axis. So that's the connection between the graph 10 to the x and 10 to the negative x. The next problem asks you to simplify the exponential functions to make sure it looks like a simple structure. So this is 2 to the power of 10 minus y, 5, they share the same base. This is 3 to the 7, this is 3 squared, so it's 3 to the 7, 3 to the 4th, 3 to the 7 minus 4, hence 3 cubed. Next problem is 2 to the 7, 2 squared to the power of 2, so 2 to the 7, 2 to the 4, so it's 2 to the 11. We have e to the 5 plus negative 1, so it's e to the negative 4. This one is 1/2 to the power of x, so it's 1 over 2 to the x, or if you want 0.5 to the x, yeah, essentially the same thing. The next problem is 6 to the power of 2 to the x, which is the same as 6 squared to the x, which is 36 to the power of x. The next problem is e to the negative x with the sign flipped, so it's e to the x. The last problem asks you to switch the graph following the instructions. So what I have is, like I said, you want to follow the order of calculation. Exponent comes first, multiplication, division comes later, and the summation, subtraction comes in the end. Therefore, the first problem is just changing the input of x. So it's a reflection. It's about horizontal manipulation. It's reflection with respect to the x-axis. The second problem, change your function value. It's not a manipulation on x. It's a manipulation of function value. So it's a vertical modification. It's reflection with respect to the x-axis. And the last problem is shift your function up because it's changing the function value. So it's a vertical manipulation. It's up by 3 units. Make sure you follow the correct order. The next problem asks you to convert back and forth between exponential structure and logarithmic structure. So we can't emphasize this enough that it's super important for you to get comfortable with the structure. One way to look at it is to show it in that order, but I mean, it's just a practice. Essentially, if you remember the output with log is exponent, that's good enough. So in this case, the 5 is the base, the 2 is the output. In this case, negative 2 is the exponent. Therefore, your function must look like this. The next one, just as a quick reminder, it's log of base e, and things 3 is exponent output, so it must be the exponent. So this is what I end up with. The next problem asks you to plot the graph, and you know the connection between exponential and logarithmic function. The output and input were going to be flipped. Therefore, if it's x, if it's negative 1, it's 1/2. It's 0, it's 1, it's 1. 2 to the power of 1 is 2, and if it's 2, 2 squared is 4. And the logarithmic function sharing the same base is flip the order of your xy component. Therefore, it's 1/2 gives you negative 1. 1 gives you 0, 2 gives you 1, 4 gives you 2. So what you have on your graph is going to be the first function is negative 1, 1. So negative 1/2 is here, 0, 1 is there, 1, 2 is up here, and then you have 2, 4 is up there. So this is your graph to the function 2 to the x. Your graph for the other function, which goes with horizontally 1/2 negative 1, so it's somewhere here, 1, 0, and then 2, 1, which is here, and then 4, 2. So your graph is something that looks like that. As a matter of fact, their connection is a reflection with respect to the line y equals x because they are inverse functions. The last problem, we went over those very carefully in class. So if I were to order them as A, B, C, D, E, F, both problem 1 and 2, they are log 10 of 1 and log E of 1. Based on the item D, you know both of them are true. The next one is force as log of anything but for 0. The domain of log function is greater than 0. Log x, x must be greater than 0, so the 0 can be an input. The following tube structure looks like A, so it's not hard for you to realize the previous one is true. The following one is force. I don't have any two log structures multiplying together, so you can tell there must be force. There's no way I can put them together. If I have two functions to be log doing subtraction, it must be the division. So I'm going to look at structure B for both of them and realize both of them are force. This one has to be flipped, so it should have been x over 2 here in order for it to be correct. The next problem is division of two log structure. We don't have formulation, looks like that, so they are both force. The next problem, the left side of it, according to property number C, it's log of 4 to the 1/2, which is square root, therefore it's ln of 2, which is true here. The next problem again is property C, which is also true. The last one is force. I can't emphasize it enough that ln of x plus 1 does not mean it's a multiplication. Okay, log of anything is not a multiplication. You can't do cancellation like that. So this makes no sense. Okay, so that's all we